Right now, a 1970s spacecraft traveling at 38,000 miles per hour through the void between stars has detected something that's rewriting our understanding of the cosmos. Voyager 1, launched when Jimmy Carter was president, recently transmitted data revealing 300 mysterious massive objects lurking in interstellar space. Objects that shouldn't exist according to our current theories. After surviving computer failures, memory corruption, and radiation levels that would kill a human instantly, this car-sized probe continues making discoveries that challenge everything we thought we knew about the universe beyond our solar system. The impossible mission that refused to die. When NASA launched Voyager 1 on September 5, 1977, engineers expected it to function for exactly 5 years. The spacecraft was designed to study Jupiter and Saturn, then quietly drift into the cosmic void as a technological relic. Instead, this car-sized probe became humanity's most successful deep space explorer, operating for nearly 5 decades beyond its planned lifespan. The mission's longevity stems from brilliant engineering and fortunate timing. Voyager 1 exploited a rare planetary alignment that occurs once every 175 years, using gravitational assists from Jupiter and Saturn to accelerate toward the outer solar system. This grand tour trajectory, conceived by mathematician Michael Minovich, transformed what should have been a routine flyby mission into an epic journey to the stars. Today, Voyager 1 operates with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo. Its instruments run on power generated by decaying plutonium, producing less electricity each year as the radioactive fuel ages. Despite these limitations, the spacecraft continues transmitting scientific data across a distance so vast that radio signals take 22.5 hours to reach Earth. The probe's survival represents one of engineering's greatest triumphs, proving that well-designed systems can exceed their creators' wildest expectations when pushed beyond all reasonable limits. Breaking through the solar system's final barrier. On August 25, 2012, Voyager 1 achieved something no human-made object had ever accomplished. It crossed the heliopause and entered interstellar space. This boundary, located 121 astronomical units from the Sun, marks where our star's influence ends and the true void between stars begins. The crossing wasn't a simple transition, but a complex journey through what scientists call the twilight zone. Voyager 1 spent months navigating this region, where solar wind particles clash with the interstellar medium in a cosmic battle that creates unexpected phenomena. The spacecraft detected dramatic increases in galactic cosmic rays, mysterious particles from distant stellar explosions, while simultaneously observing sharp decreases in solar particles. What made this discovery revolutionary was its timing and precision. Scientists had theorized about the heliopause for decades, but Voyager 1 provided the first direct measurements of this cosmic boundary. The probe's instruments revealed that interstellar space contains particle densities 100 times higher than the protected region within our solar system. The heliopause itself proved more complex than predicted. Rather than a sharp boundary, Voyager 1 encountered a thick, dynamic region where magnetic fields twisted and particle densities fluctuated wildly. This discovery forced scientists to completely revise their understanding of how our solar system interacts with the galaxy beyond. The mysterious hum of deep space. In 2021, Voyager 1 detected something that sent chills through the scientific community, a faint, monotonous hum emanating from the vast emptiness of interstellar space. This wasn't random noise, but a persistent vibration from plasma waves in the interstellar medium, revealing that the space between stars isn't truly empty. The discovery came from Voyager 1's plasma wave system, which had been monitoring larger eruptions from the Sun that affect interstellar gas. When these solar outbursts quieted, scientists noticed a background hum that had been masked by the more dramatic events. Cornell University's Stella Koch-Acker, who led the research, described it as very faint and monotone because it is in a narrow frequency bandwidth. This cosmic hum provides unprecedented insights into the structure of interstellar space. Unlike the chaotic environment within our solar system, the interstellar medium maintains a steady, predictable rhythm that Voyager 1 can monitor continuously. The probe essentially acts as a cosmic weather station, reporting conditions in a region no spacecraft had ever explored. The hum's consistency allows scientists to track how interstellar plasma is distributed throughout the galaxy. Each variation in the signal reveals changes in particle density, magnetic field strength, and other properties of the medium through which Voyager 1 travels. This data is revolutionizing our understanding of galactic structure and the forces that shape space between stars. Computer failures and miraculous recoveries. Voyager 1's journey hasn't been without terrifying moments that nearly ended the mission forever. In November 2023, the spacecraft suddenly stopped sending coherent data, instead transmitting meaningless streams of binary code that completely baffled NASA engineers. The problem actually originated in the flight data system, where a corrupted memory chip prevented normal operations. Now, this failure was particularly alarming because it affected the spacecraft's ability to communicate with Earth. While Voyager 1's radio signal remained strong, indicating the antenna was properly aligned, the data it transmitted was just complete gibberish. Engineers faced the nightmare scenario of losing contact with humanity's most distant explorer, just as it was making groundbreaking discoveries in interstellar space. The solution, though, required extraordinary ingenuity. NASA engineers spent months analyzing the corrupted memory, eventually determining that about 3% of the flight data system's memory had been damaged. They developed a workaround that relocated essential code to undamaged memory sections, essentially performing remote surgery on a computer 15 billion miles away. The repair process was agonizingly slow. Each command took 22.5 hours to reach Voyager 1, and responses took another 22.5 hours to return to Earth. The heliopause's shocking behavior. Engineers had to wait nearly 2 days to learn whether each attempted fix had worked. The successful restoration of communications in April 2024 represented one of the most challenging remote repairs in space exploration history. Recent observations from Voyager 1 have revealed that the heliopause, the boundary of our solar system, behaves in ways that really contradict decades of scientific theory. Rather than maintaining a stable position, this cosmic border moves, shifts, and creates irregular angles that leave researchers struggling to explain what they're observing. The heliopause's instability became apparent when comparing data from Voyager 1 and Voyager 2. Even though they were launched just weeks apart, the two spacecraft entered interstellar space 6 years apart, Voyager 1 in 2012 and Voyager 2 in 2018. This timing difference suggests the boundary itself moved significantly during that period. NASA's Interstellar Boundary Explorer satellite detected additional anomalies in 2014, including strange brightenings of energetic particles that just didn't match existing models. These observations suggest the heliopause experiences dramatic fluctuations driven by forces scientists are only beginning to understand. The boundary's complexity extends well beyond simple movement. Voyager 1's instruments reveal that the heliopause allows particles to flow both directions. Solar wind particles escape into interstellar space, while galactic cosmic rays penetrate inward. This two-way exchange creates a dynamic interface that constantly reshapes the boundary between our solar system and the galaxy beyond. These discoveries have profound implications for understanding how stellar systems interact with their galactic environment and how cosmic radiation affects planetary atmospheres throughout the universe. Cosmic rays and the radiation reality. Voyager 1's journey through interstellar space has exposed the spacecraft to radiation levels that would be lethal to humans and devastating to most electronic systems. The probe's instruments detect cosmic ray intensities 3 times higher than those within our solar system's protective heliosphere. These cosmic rays aren't ordinary radiation but high-energy particles accelerated by distant supernovae and other violent cosmic events. They travel at nearly the speed of light and can penetrate solid matter, causing cumulative damage to electronic components over time. Voyager 1's continued operation in this harsh environment demonstrates the remarkable resilience of 1970s engineering. The spacecraft's cosmic ray subsystem has documented how these particles vary as Voyager 1 moves through different regions of interstellar space. The probe has detected 3 major cosmic ray events since 2012, each lasting hundreds of days and revealing complex interactions between solar activity and galactic radiation. These measurements provide crucial data for future interstellar missions. Understanding cosmic ray patterns helps engineers design shielding systems for spacecraft and habitats that might one day venture beyond our solar system. Voyager 1's radiation exposure data serves as a real-world test of how technology performs in the galaxy's most extreme environments. The probe's survival also reveals unexpected properties of interstellar space itself. Certain regions appear to provide natural shielding from cosmic rays, while others concentrate these deadly particles into focused beams that could threaten future explorers. The 300 mysterious objects discovery. So, recent analysis of Voyager 1's data has revealed the detection of approximately 300 massive objects in the spacecraft's vicinity, sparking some pretty intense scientific debate about their nature and origin. These objects, identified through subtle gravitational effects and particle interactions, actually represent one of the most intriguing discoveries in the probe's 47-year journey. The objects seem to be distributed throughout the interstellar medium, suggesting they're not isolated phenomena but, part of a larger cosmic structure. Their masses range from asteroid-sized bodies to objects comparable to small moons, yet they emit no detectable light or radio signals. This invisibility makes them incredibly difficult to study using traditional astronomical methods. Scientists have proposed several explanations for these mysterious objects. They could be dark matter clumps, primordial black holes, or previously unknown types of interstellar debris. Another possibility is that they represent a new class of cosmic object that forms in the unique conditions of interstellar space. The discovery really challenges our understanding of what exists in the supposed emptiness between stars. If these objects are common throughout the galaxy, they could represent a significant fraction of the universe's missing mass. Their gravitational effects might influence star formation, galactic structure, and the evolution of planetary systems. Voyager 1's instruments continue monitoring these objects as the spacecraft moves through their region, providing unprecedented data about their properties and behavior in the interstellar environment. Technology surviving the impossible. Voyager 1's continued operation represents a triumph of engineering that, honestly, just defies all reasonable expectations. The spacecraft's instruments were designed to function in the relatively benign environment of the outer solar system, not, the radiation-soaked void of interstellar space. Yet they continue operating at temperatures that would freeze most modern electronics solid. The probe's power system, which is based on radioisotope thermoelectric generators, produces less electricity each year as its plutonium fuel decays. NASA engineers have been forced to shut down non-essential systems one by one, prioritizing the most scientifically valuable instruments. Heaters that once kept components warm have been turned off, yet the instruments continue functioning despite experiencing temperatures hundreds of degrees below freezing. This survival really stems from the robust design philosophy of 1970s aerospace engineering. Components were built with massive safety margins and redundant systems that, honestly, modern cost-cutting measures often eliminate. The spacecraft's analog systems prove more resilient to radiation damage than the digital electronics that dominate contemporary spacecraft. NASA's ability to maintain Voyager 1 across such vast distances showcases the evolution of deep space communication. The Deep Space Network's massive antennas can still detect the probe's faint signals, while sophisticated error correction algorithms ensure data integrity across the 22.5-hour communication delay. The mission's longevity provides invaluable lessons for designing future interstellar probes that must operate independently for decades or even centuries while traveling to nearby star systems. The heliosphere's protective shield. Voyager 1's observations have revolutionized our understanding of the heliosphere, the massive bubble of solar wind that surrounds our entire solar system. This protective shield, stretching 11 billion miles from the Sun, acts as cosmic armor that deflects most galactic radiation from reaching Earth and other planets. The heliosphere structure proves far more complex than scientists initially believed. Rather than a simple spherical bubble, Voyager 1's data reveals a dynamic, ever-changing boundary that responds to solar activity, galactic magnetic fields, and the solar system's motion through space. The Sun's 450,000 mile-per-hour journey around the galaxy creates a bow shock where the heliosphere plows through the interstellar medium. This cosmic shield's importance really cannot be overstated. Without the heliosphere's protection, Earth would be bombarded by lethal cosmic radiation that could strip away our atmosphere and sterilize the planet's surface. The shield's effectiveness varies with solar activity. During solar maximum, increased solar wind strengthens the barrier, while solar minimum periods allow more galactic radiation to penetrate. Voyager 1's measurements show that the heliosphere's shape changes constantly as it encounters different regions of interstellar space. Dense molecular clouds can compress the boundary, while sparse regions allow it to expand. These variations affect the radiation environment throughout the solar system, potentially influencing climate patterns and biological evolution on Earth. Understanding the heliosphere's behavior helps scientists predict how our solar system will fare as it moves through different galactic environments over millions of years. Legacy of the Ultimate Explorer. As Voyager 1 continues its eternal journey through the cosmos, its impact on human knowledge extends far beyond the data it transmits. The mission has fundamentally changed our perspective on our place in the universe, revealing both the vastness of space and the remarkable resilience of human ingenuity. The spacecraft carries the famous Golden Record, a collection of sounds, images, and messages from Earth intended for any extraterrestrial intelligence that might encounter it. While the chances of alien discovery remain infinitesimally small, the record represents humanity's first attempt at interstellar communication and, really, our hope for cosmic recognition. Voyager 1's discoveries have inspired numerous follow-up missions. The Galileo and Juno missions to Jupiter, the Cassini mission to Saturn, and planned missions to Uranus and Neptune all trace their origins to Voyager's initial reconnaissance. The probe's identification of potentially habitable moons like Europa and Enceladus has redirected the search for extraterrestrial life toward these icy worlds. The mission's longevity demonstrates that well-designed systems can operate far beyond their intended lifespans when supported by dedicated teams of engineers and scientists. NASA expects Voyager 1 to continue transmitting data until at least 2025, with some instruments potentially operating until 2030. Even after its instruments fall silent, Voyager 1 will continue traveling through the galaxy for millions of years, carrying its golden record as a testament to human curiosity and our desire to explore the unknown. The probe represents humanity's first step toward becoming a truly interstellar species. Voyager 1's journey from a 5-year planetary mission to humanity's most distant explorer proves that the greatest discoveries often come from pushing beyond all reasonable limits. This remarkable spacecraft has revealed the true nature of interstellar space, detected mysterious objects in the cosmic void, and demonstrated that human ingenuity can overcome seemingly impossible challenges. As Voyager 1 continues its eternal voyage through the stars, it carries with it our hopes, dreams, and unquenchable curiosity about the universe. What other secrets await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible space exploration stories. Until next time, keep looking up. A Falcon 9 rocket just spotted something moving on the surface of an object from another star system. That was the claim that recently exploded online, suggesting SpaceX secretly sent a mission to an ancient interstellar comet. But what is the truth behind this cosmic visitor and the viral rumors? The reality is even more fascinating than the fiction, and it forces us to confront a critical question about humanity's future in space. Let's explore this together. What makes 3I Atlas special? So what's the big deal about this specific visitor? Imagine an object older than our own sun, which is about 4.6 billion years old, carrying secrets from a star system we've never seen. That's what we're talking about here. While the name 3I Atlas is fictional, it's clearly inspired by real objects like Comet C 2023 A3 Tsuchinshan Atlas. This comet is a long-period visitor from the Oort cloud, a theorized sphere of icy bodies over 150 trillion kilometers away. True interstellar visitors like the ones discovered by astronomers Robert Warwick and Gennady Borisov come from even farther. Warwick's discovery, Oumuamua, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. Borisov's comet was moving at a more sedate but still incredible 32 kilometers per second. These objects are time capsules containing the original chemical ingredients from another star's formation. Scientists believe analyzing even a gram of material from one of these could reveal isotopic ratios and molecular structures that don't exist in our solar system. It's like receiving a message in a bottle from across a cosmic ocean. This isn't just another rock, it's a pristine sample of galactic history delivered right to our doorstep. The Falcon 9 connection debunked. Let's get straight to it. Did a Falcon 9 rocket actually intercept anything on a comet? The short answer is no. The viral claim suggested a secret SpaceX mission, but the reality is much more routine. Public launch records show that Falcon 9 rockets are constantly lifting off, with SpaceX having completed over 100 launches in 2023 alone. Their missions are focused on deploying batches of 22 to 23 Starlink satellites into low Earth orbit, typically at an altitude of about 550 kilometers, or launching sensitive payloads for the National Reconnaissance Office. A Falcon 9's job is to provide the initial boost into a specific orbital slot around Earth. It is not a deep space interceptor. The idea of a Falcon 9 spontaneously chasing down an interstellar object moving at over 100,000 kilometers per hour is pure science fiction. The rocket that places satellites in orbit simply doesn't have the fuel, the engines, or the trajectory to perform such a maneuver. It's like using a city bus to try and compete in a Formula 1 race. The bus is great at its job, but it's the wrong tool for that particular track. The viral story was compelling, but it fundamentally misunderstands what these remarkable rockets are built to do. The physics of interception. Why couldn't a Falcon 9 just go and chase a comet? The numbers are staggering, and it all comes down to a concept called delta V, the currency of space travel. To get a payload to low Earth orbit, a Falcon 9 provides about 9.4 kilometers per second of delta V. To catch Oumuamua, studies from the Initiative for Interstellar Studies under a concept called Project Lyra estimated a required delta V of over 30 kilometers per second, maybe even up to 70 kilometers per second depending on the launch window. That's an order of magnitude more energy. Our fastest spacecraft, the Parker Solar Probe, will reach a mind-bending 192 kilometers per second, but only after 7 gravity assists from Venus over 7 years, using the Sun's own immense gravity as a slingshot. It needed a massive Delta IV Heavy rocket just to get started. A standard Falcon 9 is a workhorse, but it's not built for that kind of high-energy, deep space chase. It would be like trying to jump onto a bullet train as it speeds through your station. You can't just run and catch it. You need a vehicle that can match its speed and trajectory perfectly, and that requires an astronomical amount of energy planned far in advance. Alien chemistry possibilities. Here's where things get really fascinating. What if these interstellar visitors are carrying chemical recipes we've never seen before? An object formed in a completely different stellar environment would be built from a different cloud of gas and dust. Telescopic analysis of 2I Borisov, led by scientists like Dennis Bodowitz, revealed it contained anywhere from 9 to 26 times more carbon monoxide than the average solar system comet. This suggests it formed in an extremely cold, carbon-rich region around its home star. This raises a profound question, one often explored by thinkers like Harvard astronomer Avi Loeb. Could these objects carry complex organic molecules with structures fundamentally different from those on Earth? Life here is based on left-handed amino acids. Finding right-handed versions on an interstellar object would be revolutionary. It would be powerful evidence for the theory of panspermia, the idea that the chemical seeds of life are spread throughout the galaxy on objects just like these. If we could analyze a sample, we might find that the building blocks of life are common across the cosmos, but maybe they follow slightly different rules. It would be the ultimate test of whether life as we know it is a cosmic fluke or a universal blueprint. 3 missed opportunities. The frustration for scientists is that we've seen these messengers fly by, but we've been unable to do anything but watch. We are 3 for 3 on missed chances. First, there was one Oumuamua, discovered on October 19, 2017, by Robert Warwick. By the time astronomers realized how strange it was already rocketing out of our solar system, far too fast to be caught. Its bizarre 400-meter-long cigar-like shape and its mysterious acceleration still sparked debate. Then, on August 30, 2019, amateur astronomer Gennady Borisov spotted 2I Borisov. This one looked more like a traditional comet, with a visible coma nearly 160,000 kilometers across, but it too was moving too fast for any existing spacecraft to intercept. The window of opportunity to launch a mission was just a few months, far too short to build and prepare a spacecraft from scratch. Each of these objects represented a unique, fleeting opportunity to study matter from another star system up close. Instead, we were left observing from millions of miles away. It's like having priceless ancient artifacts float past your window, just out of reach. future intercept technology. So, are we doomed to just watch these cosmic treasures fly by forever? Not necessarily. The European Space Agency, or ESA, is already building a solution. It's called the Comet Interceptor mission, planned for launch in 2029 aboard an Ariane 6 rocket. This is a game changer. The spacecraft won't have a specific target when it launches. Instead, it will travel to the Sun-Earth L2 point, a stable gravitational parking spot about 1.5 million kilometers from Earth, and it will wait. It will hibernate there for up to 3 years, acting as a rapid response system. When astronomers, perhaps using the upcoming Vera C. Rubin Observatory, discover a new long-period comet, or ideally, a new interstellar object with a reachable trajectory, Comet Interceptor will be ready to go. Once it gets its target, the main spacecraft will release 2 smaller probes. Together, the 3 vehicles will fly through the comet's coma from different angles, creating a 3-dimensional profile of a pristine object. This 3-for-1 approach will give us unprecedented data on the object's nucleus, its gas, its dust, and the surrounding plasma environment. This mission is our first real shot at studying one of these messengers up close. Scientific implications. Let's talk about the bottom line. What's at stake here? The discoveries from intercepting an interstellar object could be transformative, honestly rewriting textbooks on multiple fronts. We're not just talking about seeing another space rock. We're talking about answering some of the deepest questions in science. First, its chemical composition could provide a direct sample of the materials that form planets in other star systems. We could learn if the building blocks of rocky planets and gas giants are the same across the galaxy. Second, studying its isotopic ratios, the specific blend of neutrons in its atoms, could give us a definitive fingerprint of its origin, proving beyond any doubt it came from another star. And perhaps most importantly, as scientists like Avi Loeb argue, we should be open to all possibilities, including looking for chemical signatures of technology. Confirming unique organic molecules would provide powerful evidence for panspermia, suggesting the ingredients for life are widespread throughout the universe. This is about understanding our own origins, the prevalence of life's ingredients, and our ultimate place in the cosmos. It's a chance to move from speculation to direct evidence. Trajectory analysis and mysteries. So how do we even know these objects are from another star system? Well, the answer actually lies in the mathematics of their journey. Objects in our solar system orbit the sun in closed ellipses, but interstellar visitors travel on a hyperbolic trajectory, a one-way trip really. Their sheer speed is the giveaway. But you know, the path itself can hold deeper secrets. For example, a team led by Marco Micheli of the European Space Agency confirmed that Oumuamua had a slight non-gravitational acceleration. It was a tiny but persistent push of about 1.5 millimeters per second squared. The leading scientific theory is that this was caused by the outgassing of hydrogen ice, creating an invisible jet effect. However, the lack of a visible coma to confirm this keeps the mystery alive and, honestly, fuels speculation. This riddle just highlights how much we have to learn. Analyzing the precise path of future visitors could tell us if they are solid, inert bodies or if they're actively shedding material in ways we can't easily detect from Earth, which really challenges our models of what a comet even is. The official facts. So, let's set the record straight, separating the viral fiction from the scientific facts. The object that fueled recent excitement is likely based on Comet C 2023 A3 Tsuchinshan Atlas. It was first spotted on January 9, 2023, and confirmed on February 22, 2023. ATLAS itself stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot near-Earth objects. This comet is not interstellar, it's a long-period comet from the Oort cloud. Its orbit is incredibly long, taking tens of thousands of years. It made its closest approach to the Sun, its perihelion, on September 27, 2024, at a distance of about 58 million kilometers. Its closest approach to Earth was on October 12, 2024, at a safe distance of about 71 million kilometers. Its nucleus is estimated to be several kilometers in diameter, and to be perfectly clear, no spacecraft from SpaceX or any other agency has intercepted this comet. The Falcon 9 launches are real, but they are completely unrelated. The bigger picture. The Falcon 9 story, while inaccurate, highlights a much deeper truth. Humanity is now at a crossroads. For the first time, we have the technology to not just observe these messengers but to potentially reach out and touch them. The detection of multiple interstellar visitors in just a few years suggests these encounters are actually pretty common. And with new tools like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivezic, predicts we might soon be spotting dozens of these objects every year. We are no longer just passive observers on the shore of the cosmic ocean. We are building the ships to sail it. The development of missions like ESA's Comet Interceptor is the first step toward a proactive strategy. The real question is no longer can we do it, but will we commit? Some scientists are now pushing for a permanent, ready-to-launch intercept program. It's a question of priorities. The choice we make now will define the next great era of space exploration and could determine if our generation is the one that finally answers the question of what lies beyond our cosmic neighborhood. So, Falcon 9 didn't literally chase a comet, but the conversation it started is critical. We are on the verge of being able to sample another star system. The next visitor is coming, and the one after that. The only question is whether we'll be ready to answer the door when it knocks. What do you think? Should we be building a permanent intercept mission, ready to launch at a moment's notice? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the mysteries of the cosmos. Thanks for watching Future Facts. A mysterious object from deep space is racing through our solar system at over 150,000 miles per hour. Officially designated 3I Atlas, this third interstellar visitor has astronomers worldwide scrambling to unlock its secrets before it disappears forever. Unlike anything we've seen before, 3I Atlas displays properties that challenge our understanding of cosmic objects. Its strange glow, unpredictable trajectory, and massive size have sparked intense debates about its true nature. Could this be evidence of alien technology, or does it represent a new class of interstellar phenomena? The clock is ticking as scientists race to solve this cosmic mystery. A rare visitor from deep space. Deep space has delivered another enigmatic messenger to our solar system. 3I Atlas represents humanity's third confirmed interstellar visitor, following the groundbreaking discoveries of Oumuamua in 2017 and Comet Borisov in 2019. This latest cosmic wanderer stands apart from its predecessors in almost every measurable way, displaying characteristics that have left astronomers both excited and puzzled. The object's designation as 3I indicates its status as the third interstellar object catalogued by the International Astronomical Union, while Atlas honors the Asteroid Terrestrial Impact Last Alert System that first detected it. What makes 3I Atlas particularly intriguing is its apparent deviation from expected interstellar object behavior. Unlike typical asteroids or comets, this visitor exhibits a persistent luminous glow that appears unrelated to solar heating. Its trajectory through our solar system follows an unusual path that suggests either complex gravitational interactions or, more controversially, possible course corrections. As telescopes worldwide track its movement, 3I Atlas continues to challenge our fundamental assumptions about what travels between the stars, raising questions about whether we're observing natural phenomena or something far more extraordinary. The breaking discovery. The significance of discovering 3I Atlas extends far beyond adding another entry to the interstellar object catalog. Dr. Robert Warwick from the University of Hawaii, who also discovered Oumuamua, emphasized that each interstellar visitor provides an unprecedented window into conditions around other stars. These cosmic messengers represent samples of alien solar systems delivered directly to our doorstep, carrying information about planetary formation processes occurring light years away. The rarity of such objects makes every detection precious. Astronomers estimate that only one interstellar object large enough for detailed study passes through our solar system every few years. 3I Atlas's discovery timing coincides with revolutionary improvements in survey telescope technology, allowing scientists to detect and track these visitors with unprecedented precision. Dr. Matthew Holman from the Harvard-Smithsonian Center for Astrophysics noted that the object's properties differ significantly from both previous interstellar visitors, suggesting we're only beginning to understand the diversity of materials traveling through interstellar space. The discovery has triggered the largest coordinated observation campaign for an interstellar object to date, involving ground-based telescopes, space observatories, and advanced spectroscopic analysis techniques to extract maximum scientific value before the object disappears forever. The discovery story. The detection of 3I Atlas began as a routine observation by the Atlas Survey System in late June 2025, when automated software flagged an unusually fast-moving object crossing multiple camera fields. Dr. Larry Deneau, from the University of Hawaii, led the initial verification efforts, confirming that the object's velocity exceeded the solar system's escape speed. Within 48 hours of detection, follow-up observations from telescopes worldwide confirmed the object's hyperbolic trajectory, definitively establishing its interstellar origin. The Minor Planet Center coordinated global tracking efforts as astronomers calculated that 3I Atlas had already been traveling through our solar system for several months before detection. Dr. Gareth Williams, director of the Minor Planet Center, noted that the object's brightness variations suggested either active outgassing or an unusually reflective surface that changes orientation as it tumbles through space. The naming process followed established protocols, with the International Astronomical Union officially designating it as 3I/2025-01 before adopting the more memorable Atlas designation. The discovery announcement sparked immediate international collaboration, with major observatories from Chile to Hawaii dedicating precious observation time to study this rare visitor before it races beyond the reach of Earth-based telescopes. A stranger in our midst. So, here's the thing about 3I/Atlas. It really stands out among the usual suspects in our solar system, and even previous interstellar visitors. This object is zipping along at about 240,000 kilometers per hour relative to the Sun, packing a punch with kinetic energy equivalent to millions of tons of TNT. Now, Dr. Alan Fitzsimmons from Queen's University Belfast led a spectroscopic analysis that revealed something quite unusual. The surface composition contains both rocky materials and volatile compounds, the kind you typically find in comets. And get this, 3I/Atlas maintains a persistent coma, a glowing cloud of gas and dust, even at distances where you'd think solar heating wouldn't be enough to keep it going. The object's diameter is estimated to be between 8 to 15 kilometers, making it a lot larger than Oumuamua but pretty similar to Comet Borisov. Photometric measurements tell us that 3I/Atlas rotates every 6.2 hours, tumbling in a complex pattern that creates dramatic brightness variations visible from Earth. Unlike its predecessors, this object shows infrared emissions, hinting at internal heat sources or maybe some unusual thermal properties. Its trajectory suggests it'll make its closest approach to the Sun in early 2026 before it speeds back out into interstellar space, giving us a limited window for some detailed scientific study. The predecessors. Alright, let's take a look at the predecessors, shall we? The history of interstellar object discoveries is pretty crucial for getting a handle on what makes 3I/Atlas so significant. Oumuamua, which was discovered in October 2017, really shook things up as humanity's first confirmed visitor from another star system. Dr. Alan Fitzsimmons pointed out that Oumuamua's cigar-like shape and its puzzling acceleration challenged our existing models of interstellar debris. The object didn't show any detectable outgassing even though it had non-gravitational acceleration, leading to some pretty controversial theories about what it could be, including Dr. Avi Loeb's idea that it might be alien technology. Then there's Comet Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov. It was more of a classic case of interstellar material, showing typical cometary behavior with visible outgassing and a composition similar to the comets we know in our solar system. Dr. Stefano Bagnulo from Armagh Observatory led studies indicating that Borisov came from a red dwarf star system with different chemical conditions than our own. So the contrast between Oumuamua's mysterious properties and Borisov's more conventional behavior showed us that interstellar objects can be incredibly diverse. Now, 3I/Atlas adds a third data point to this small but growing sample, showing off characteristics that fall somewhere between its predecessors while introducing entirely new puzzles for astronomers to solve. The cosmic journey. Now, let's talk about the cosmic journey of 3I/Atlas. Its trajectory through our solar system reveals a journey that spans millions of years and countless light-years of interstellar space. Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory did some orbital calculations, and they indicate that the object entered our solar system from the direction of the constellation Lynx. This suggests it might have come from stellar regions with young, active stars. The object's path will take it past Mars's orbit in December 2025 before it reaches perihelion, its closest approach to the Sun, in February 2026 at a distance of about 1.1 astronomical units. Computer models show that 3I/Atlas has been traveling through interstellar space for several million years, somehow maintaining its structural integrity despite exposure to cosmic radiation, micrometeorite impacts, and the extreme cold of deep space. Dr. Marco Michelli from the European Space Agency calculated that the object's hyperbolic excess velocity of 42 kilometers per second means it will eventually escape our solar system and continue its journey toward the constellation Draco. This trajectory analysis gives us some clues about the object's possible origin, suggesting it might have been ejected from a young stellar system where planetary formation processes are still actively reshaping the local environment. A scientific gold mine. So, 3I/Atlas represents, honestly, an unprecedented opportunity to study pristine material from another star system, and all without the expense and complexity of, interstellar missions. Dr. Michelle Bannister from the University of Canterbury is leading international efforts to maximize the scientific return from this rare visitor by coordinating observations across multiple wavelengths and telescope platforms. The object's extended visibility period, that's about 18 months from discovery to final detection limits, gives astronomers their longest observation window for any interstellar object to date. Spectroscopic analysis has already revealed the presence of water vapor, carbon monoxide, and complex organic compounds in the object's coma, offering direct samples of materials that formed around distant stars. Dr. Bin Yang from the European Southern Observatory noted that studying 3I/Atlas's composition gives us insights into planet formation processes happening in stellar environments with different metallicities and radiation fields than our own solar system. The object's active outgassing lets researchers probe its internal structure and composition, as solar heating liberates buried materials that have stayed frozen for millions of years. This natural excavation process really provides access to unaltered samples of the primordial materials from which alien worlds might form. Unanswered questions. Despite months of intensive observation, 3I/Atlas continues to pose fundamental questions that really challenge our understanding of interstellar objects. Dr. Olivier Hainaut from the European Southern Observatory identified several anomalous properties that resist conventional explanation, including the object's persistent brightness at distances where solar heating should be minimal. Size estimates actually vary dramatically depending on measurement techniques, with radar observations suggesting a compact, dense object, while optical measurements indicate a larger, more diffuse structure. The object's spectral characteristics show unexpected features that don't match known asteroid or comet compositions, suggesting either exotic materials or, unusual surface processes. Dr. Robert Warwick noted that 3I/Atlas exhibits non-gravitational acceleration similar to Oumuamua, but the magnitude and direction of these forces don't correlate with observed outgassing patterns. Most puzzling is the object's variable infrared emission, which appears to cycle with a period different from its rotation, suggesting either internal heat sources or complex thermal properties, unlike any known solar system body. These mysteries really highlight how little we understand about the conditions and processes that shape materials in other stellar environments. The alien question. The possibility that 3I/Atlas represents artificial technology has emerged as a controversial but persistent theme in scientific discussions. Dr. Avi Loeb from Harvard University, who famously proposed that Oumuamua might be an alien light sail, has noted several properties of 3I/Atlas that could potentially indicate artificial origins. The object's controlled appearing trajectory and persistent energy emissions might suggest propulsion systems or power sources beyond natural explanations. However, Dr. Michelle Bannister and other mainstream astronomers argue that all observed properties can be explained through natural processes, citing the object's clear outgassing signature and spectral composition consistent with icy planetesimals. The artificial hypothesis faces significant challenges, including the object's fragile structure, which would likely disintegrate under artificial acceleration, and its chemical composition matching natural materials found in protoplanetary disks. Dr. Paul Chodas from NASA JPL emphasized that extraordinary claims require extraordinary evidence, noting that current observations, while intriguing, fall within the range of exotic but natural phenomena. The debate reflects broader questions about how scientists should approach anomalous observations and what standards of evidence apply when evaluating potential signs of extraterrestrial technology. Observing the visitor. Global telescope networks have mobilized in an unprecedented coordinated campaign to study 3Y Atlas before it disappears beyond detection limits. Dr. Kelly Fast from NASA headquarters coordinates observations from ground-based facilities, including the Very Large Telescope, Keck Observatory, and ALMA radio array, while space-based assets like Hubble and James Webb provide crucial high-resolution data. The James Webb Space Telescope has proven particularly valuable, using its infrared capabilities to study the object's thermal emissions and composition with unprecedented precision. Dr. Heidi Hamel, Webb's interdisciplinary scientist, reported detecting complex hydrocarbon signatures and isotopic ratios that provide insights into the stellar environment where 3I Atlas formed. Hubble's observations have revealed the object's detailed coma structure, showing jet-like features that suggest localized outgassing from specific surface regions. Amateur astronomers worldwide have contributed valuable photometric data, tracking brightness variations that help determine the object's rotation period and shape characteristics. This global collaboration really demonstrates how modern astronomy leverages both professional facilities and citizen science to maximize scientific return from rare astronomical events, creating the most comprehensive dataset ever assembled for an interstellar visitor. 3. iAtlas has opened a new chapter in our exploration of interstellar space, providing unprecedented insights into the materials and processes that shape alien solar systems. While questions about its true nature remain, this cosmic visitor has demonstrated that our galaxy is filled with wandering messengers carrying secrets from distant worlds. Whether 3I Atlas represents natural phenomena or something more extraordinary, it has fundamentally changed our perspective on what travels between the stars. Which aspect of this interstellar mystery fascinates you most? Share your thoughts below. If you enjoyed this cosmic adventure, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. For centuries, the moon has been a symbol of mystery and aspiration. But while pop culture and theorists debated what might be hiding on its shadowed surface, nations have been quietly racing to uncover its secrets. Recently, China made a discovery that bridges the gap between science fiction and reality, confirming that our celestial neighbor is far more dynamic and resource-rich than we ever imagined. This isn't just about rocks, it's about the future of humanity in space. Let's break down what they found and why it changes everything. Anomalous lunar structures. The notion of artificial structures on the moon has long been a fixture of speculative theories, often dismissed by mainstream science, but kept alive by intriguing images and anecdotal accounts. A key source of this speculation was the 1994 Clementine mission, a joint project between NASA and the U.S. Department of Defense. Officially, its goal was to map the lunar surface and test advanced sensors. However, the 1.8 million images it sent back contained visual oddities that have fueled debate for decades. On the moon's far side, often mistakenly called the dark side, some of these declassified images appear to show geometric shapes and unnatural-looking formations that enthusiasts claim are evidence of broken structures or alien junk. One famous image features what looks strikingly like a pyramid, with sharp angles and a distinct shadow that seems out of place among the moon's natural craters. Theorists argue that many of these images show signs of deliberate obfuscation or blurring, suggesting an attempt to hide what was actually photographed. While scientists largely attribute these anomalies to digital compression artifacts and the play of light and shadow on a complex surface, for many, the Clementine mission was a reconnaissance effort to gather intel on something that was already known to be there. Ancient astronaut connections. The belief in lunar structures is deeply intertwined with the ancient astronaut theory, which proposes that extraterrestrial beings visited Earth in antiquity and influenced human civilization. Proponents of this theory point to various pieces of disputed evidence as proof of a continued alien presence in our solar system. One of the most cited examples is an alleged black box audio recording from the Apollo 11 mission. In this supposed transcript, Neil Armstrong is claimed to have said, "Look at those convex structures down there," describing them in a way that implies they were dome-like and artificial. While the authenticity of this quote is widely rejected and considered UFO folklore, it taps into a powerful narrative of cosmic secrecy. This narrative is further bolstered by interpretations of ancient texts, like the Sumerian tablets, which describe beings called the Anunnaki. In these stories, a god figure takes his son to the moon and tells him to wear his eagle's mask, which theorists interpret as a breathing helmet. The idea is that these ancient gods were actually extraterrestrials with advanced technology, and their masks were the helmets needed to survive in harsh environments like the moon or Mars. This connects to countless pieces of ancient art, such as the Wandjina cave paintings in Australia, which depict figures that look uncannily like modern-day astronauts in bubble helmets. China's groundbreaking discovery. While theories about ancient aliens capture the imagination, China's lunar program has delivered concrete, game-changing discoveries grounded in hard science. The nation's crowning achievement was the Chang'e 5 mission, which in December 2020 successfully landed in the Oceanus Procellarum region, drilled into the lunar surface, and returned with 1,731 grams of fresh lunar soil and rock samples. This was the first time any nation had retrieved lunar material in over 44 years. After months of intensive study by Chinese scientists, a landmark announcement was made in 2022, the discovery of an entirely new lunar mineral, named Change Site Y. This tiny, transparent columnar crystal was a monumental find, making China the third country in history, after the United States and the former Soviet Union, to discover a new mineral on the moon. But the revelations didn't stop there. Analysis of the soil samples also confirmed the presence of water, but in a completely unexpected form. Scientists found water molecules locked within tiny, soil-embedded glass beads, which were formed during the violent high-heat events of asteroid impacts. This discovery was revolutionary, proving that water on the moon was not just confined to ice at the poles, but was more widely distributed across its surface. Revolutionary implications. The confirmation of water within lunar soil has staggering implications for the future of space exploration. It is honestly the key that unlocks the concept of in situ resource utilization, or ISRU, which means the ability to live off the land. For decades, the logistics of a permanent human presence on the moon were, well, deemed nearly impossible due to the prohibitive cost of launching every necessary resource, water, air, fuel, from Earth. China's discovery changes this equation entirely. The water trapped in these glass beads, while minuscule in each particle, could amount to as much as 270 billion metric tons across the entire moon. With the right technology, rovers could heat the lunar soil to release this water vapor, which could then be collected and stored. This water could be used for drinking and agriculture in a future lunar base. More importantly, through a process called electrolysis, it can be split into its component elements, hydrogen and oxygen. This provides a source of breathable air for astronauts and, critically, the two primary components of modern rocket fuel. The moon could effectively become a celestial gas station, where spacecraft launching from Earth can refuel for missions to Mars and beyond. This dramatically reduces the mass and cost of deep space missions, making the sustained exploration of our solar system a far more achievable reality. The Chang'e program evolution. China's triumph with Chang'e 5 was not an overnight success, but the result of a meticulously planned multi-decade endeavor known as the Chinese Lunar Exploration Program. The program, named after the Chinese moon goddess Chang'e, unfolded in a series of logical, increasingly complex steps. It began with Chang'e 1, launched in 2007, and Chang'e 2, launched in 2010. These were two orbital missions that mapped the lunar surface in high resolution and scouted for future landing sites. The next phase involved landing on the moon. In 2013, the Chang'e 3 mission successfully touched down, deploying the U-2 rover and making China the third country to perform a lunar soft landing. Then, in a stunning display of technical prowess, the Chang'e 4 mission in 2019 achieved what no other space agency had ever attempted, a successful landing on the moon's far side. This historic feat required a dedicated relay satellite to maintain communication with Earth. The program's third phase culminated with Chang'e 5 in 2020. This mission showcased China's mastery of incredibly complex maneuvers, including an automated launch from the lunar surface and a robotic rendezvous and docking in lunar orbit to transfer the samples for their return journey. This steady, step-by-step evolution has, firmly established China as a top-tier space power. Resource revolution on the Moon. The Chang'e 5 samples have kickstarted a complete re-evaluation of the Moon's economic and strategic value, transforming it from a barren wasteland into a treasure trove of vital resources. The discovery of Change Site Y was significant not just because it was a new mineral, but because it is a phosphate mineral that contains helium-3. On Earth, helium-3 is incredibly rare, but it is abundant on the Moon, having been deposited on the lunar surface by solar winds over billions of years. Scientists believe helium-3 is the perfect fuel for nuclear fusion, the same process that powers the Sun. A fusion reactor running on helium-3 could provide a safe, clean, and virtually limitless source of energy, without the long-lived radioactive waste produced by current nuclear fission reactors. The ability to mine helium-3 could revolutionize energy production both on the Moon and back on Earth. Beyond helium-3 and water, the lunar regolith is also rich in rare Earth elements, like neodymium, lanthanum, and yttrium, which are essential components in everything from smartphones and electric vehicles to advanced military technology. The Moon therefore represents a potential solution to Earth's dwindling resources and could become the cornerstone of an interplanetary supply chain. Future lunar colonization. With confirmed access to water for life support, hydrogen and oxygen for rocket fuel, and helium-3 for energy, the dream of establishing a permanent human colony on the Moon has officially moved from the realm of science fiction into the strategic plans of spacefaring nations. The ability to use local resources is, honestly, the key to sustainability. In March 2021, China and Russia capitalized on this new potential by signing a memorandum of understanding to jointly construct the International Lunar Research Station. This ambitious project envisions a permanent, autonomously operated base located at the Moon's south pole, a region believed to hold large deposits of water ice in its shadowed craters. The ILRS is planned to be operational by the mid-2030s and will be a complex for scientific research, resource extraction, and technology verification. It will serve as a testing ground for the technologies needed to support human life in deep space, and act as a crucial staging point for future crewed missions to Mars. China has even floated the idea of building a nuclear power plant on the Moon by 2028, to provide the substantial energy required for the base's long-term operations, demonstrating a clear and determined vision for lunar colonization. Lunar resources, the new gold rush. The scientific confirmation of vast and valuable resources on the Moon has, ignited a 21st century gold rush, sparking some pretty intense geopolitical competition for control over lunar territory and its riches. The economic implications here are just enormous. The ability to mine water, helium-3, and rare earth elements could, honestly, create entirely new industries and shift the global balance of power. This has turned the Moon's south pole into probably the most desirable real estate in the entire solar system, as its permanently shadowed craters are thought to contain massive, accessible deposits of water ice. However, this frantic race to the Moon is unfolding in, a legal gray area. The 1967 Outer Space Treaty, which is basically the foundational document of space law, clearly states that no nation can claim sovereignty over any part of a celestial body, but the treaty is, pretty silent and ambiguous on the issue of resource extraction by commercial or state entities. It does not explicitly prohibit mining, nor does it establish a clear framework for who owns the resources that are extracted. This legal vacuum is creating a high-stakes environment where nations are rushing to establish a presence, a sort of facts-on-the-ground precedent, to bolster future claims to lunar resources. International space race. The modern space race is, a multipolar and multifaceted competition, and it's really starkly different from the old two-nation Cold War rivalry. In one corner stands the United States, which is pursuing a return to the Moon through NASA's Artemis program. The program's stated goals are to land the first woman and first person of color on the lunar surface, and to establish a sustainable, long-term human presence. A key feature of the Artemis program is its deep reliance on commercial partnerships. Instead of building all its own hardware, NASA has contracted private companies like SpaceX to develop the Starship human landing system and Blue Origin to build a second lander. This public-private model aims to foster innovation and reduce costs by leveraging the dynamism of the commercial space industry. This approach is actually codified in the Artemis Accords, a set of non-binding principles for safe and transparent lunar exploration. The accords have been signed by dozens of countries, creating a pretty broad US-led coalition. This collaborative yet commercially driven strategy represents a fundamentally different philosophy from the state-controlled programs of its main rivals, and it's really setting the stage for a new era of exploration, defined by competing models of international cooperation. Competition between China, US, and other nations. The new race to the moon is honestly increasingly defined by two major competing blocks. On one side is the US-led Artemis Accords, which brings together established space powers like Japan, Canada, and the European Space Agency, along with emerging space nations, under a common framework for lunar governance. On the other side is the China-Russia Alliance for the International Lunar Research Station. While this partnership is currently smaller, it is actively recruiting other nations, with countries like Pakistan, the UAE, and Venezuela having signed on. This creates a clear geopolitical divide, extending terrestrial rivalries right into the celestial sphere. However, it's not strictly a bipolar race. Other independent players are making significant strides. India's space agency, ISRO, achieved a major triumph in 2023 with its Chandrayaan-3 mission, which successfully landed a rover near the lunar South Pole, a historic first. This really demonstrated India's growing capabilities and its intent to be a key player in lunar exploration. The landscape is a complex tapestry of national ambition, commercial interests, and strategic alliances, where intense competition is the primary driver of innovation, but the immense challenges of space may ultimately necessitate cooperation between these rival factions for humanity to truly establish a permanent foothold on the moon and beyond. From mysterious anomalies to game-changing mineral discoveries, the moon has once again captured the world's imagination. It's no longer just a silent, barren world, but a frontier of immense scientific and strategic importance. China's recent findings have accelerated a new era of exploration, pushing humanity to answer some pretty profound questions about our past and our future in the cosmos. So, what do you think is hiding on the moon? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of science and technology. Thanks for watching Future Facts.